All right, so we'll start off with a couple practice here. Let's say we're starting off with $50,000 compounded yearly. All right, try these two different options. You got option A, option B. Option A says you have a 4.1% interest rate for 20 years. Option B, 4.7% for 15 years. Okay, find out how much money you'll have after those 20 and 15 years. All right, so on this first one, start with our $50,000, so that's our starting value. Okay, it's 1 plus our interest rate, so we got to move it to the left. So 1.041. We're raising it to the 20. Put that into the calculator. After 20 years, that 50,000 turns into $111,682.36. Option B, okay, very similar. Start with our 50,000. Their new multiplier should be 1.047. Okay, 1 plus our interest rate of 4.7%. New exponent since we're only doing it for 15 years. So 50,000 times 1.047 for 15 years. Has a return of $99,579.57. Okay, so if you were going to be given those two options for investment purposes, hopeful to know which one's going to give you a better return. Okay, the other thing we talked about is what if it's not compounded yearly, compounded quarterly, monthly, daily, weekly. Okay, so let's say we have an initial investment of 10,000. Let's say the length of our investment is 15 years. And let's say we have an interest rate of 3.5%. Okay, so I want you to look at two different things. What if it's compounded yearly, which is what we've just been doing? Let's say it's compounded quarterly. And let's say it's compounded monthly. Okay, so you get three different situations. Okay, your compound is what's going to be different. Okay, compounded yearly, what's we've been doing. Okay, look back and try and remember, how does compounding quarterly and monthly going to affect our equation? All right, so compounded yearly. Okay, same thing we've been doing, initial investment, 10,000. 1 plus our interest rate, which is 0.035 as a decimal for 15 years. Clean it up a little bit, 1.035 to the 15th. Okay, so that 10,000 after 15 years is now $16,573 or $753. And 49 cents. Hey, if we're going to compound quarterly, how many times a year is that going to be? Just say it out loud. It's not 4. Thank you. Compounding quarterly means we are compounding 4 times a year. Okay, it means we have to split up our interest rate 4 times over the year. Okay, but we're going to compound 4 times as often. So our initial investment stays the same. Okay, we're splitting up our interest rate over the course of 4 times a year. But we're going to compound 4 times as often. So we have to multiply our length by 4 as well. Okay, so 0.035 divided by 4 gives us a new multiplier. 1 plus 0.00875. 15 times 4 is 60. So 10,000 times 1.00875 raised to the 60th. Means after 15 years, we'd have $16,866.03. If we compound monthly, how many months are in a year? 12. So we still have 10,000, still 1 plus 0.035. And now we're dividing it over 12. 15 years, 12 times a year, 15 times 12 becomes our exponent. All right, so on the calculator, we get a number that looks like this when we try to split up our interest rate. Okay, so we can round it off. If you round it off, now you don't exactly have enough answer. You don't have an exact answer. Okay, so we can, if you have a fancy calculator, you can put it in all in one step. Like this. Okay. And you get an exact answer of $16,891.68. Okay, if you rounded it off, like let's say you just call it 1 point. It's our exact. Let's say you rounded it off and said 1.00 0.29. 15 times 12, actually no, 180. Okay, so if you did that, it'll be a little bit different. Okay, about 50 bucks off. Okay, if you put it in a calculator in one step, you get more of an exact answer. Okay, so notice all very similar, right? 16,753, 16,866, 16,859, okay, 891. Wow. Okay. Struggling being able to read. Okay, you got these three, they're all pretty close. If you got one answer that was like way off, okay, you should recognize that they are a little bit different. Okay, now let's say you buy a car. For $20,000. Okay, so let's say you have a car, you bought a car for $20,000. If you know anything about cars, okay, they depreciate in value. Okay, so if they depreciate in value, means they're going down, okay, by 8% each year. And now you need to figure out how much it's going to be worth after 5 years. Okay, so a very similar setup. Still have our initial value of 20,000. We still have our exponent of 5 because it's going to, we're being asked, what is it worth over the course of 5 years? Okay, so the big difference is, what is our multiplier now? Arjun, I have a feeling you know, but I'd like to see if anybody else knows or has an idea. Lucas, I know you have an idea, but I'd like to see anybody else. Dulce, give me a guess. What's our multiplier going to be, or how can we find our multiplier?
1 minus.
So Dulce says 1 minus what?
Oh,
0.08. Very good. Since it's depreciating, we're not adding our interest rate, we are subtracting it. Okay, so common things I see on here is that people just plug in 0.08 as opposed to saying 1 minus 0.08. Okay, so make sure if it depreciates in value, it's the same thing, 1 plus or minus your interest rate or your, depreciation rate. Okay, so we got 20,000 times 0.92 raised to the 5th power. So after 5 years, your $20,000 car is now only worth $13,181.63. Okay, take a look at these 4 examples. First one, depreciating in value on a boat. Buy it for $50K. Depreciates in value by 12% yearly. I figure out how much it's worth in 10 years. Second one, similar to what we were doing earlier, you got a $25,000 investment, increases by 4.5% per year for 10 years. Figure out how much you have yearly, quarterly, and weekly. If it is compounded yearly, quarterly, and weekly. All right, so the first one, we are depreciating in value. We have our starting value of $50,000 for your boat that you just bought. It's pretty sweet. Okay, 1 minus our interest rate of 12% or depreciation rate. Okay, raised to the 10th power, so your multiplier should have been 0.88. Meaning that after 10 years, you're looking to resell your boat. Buy a new one. It's worth about $13,925.05. Okay, so here we're investing 25,000. We have a rate of 4.5% for 10 years. We want to do it yearly. Very simple, 25,000. 1 plus 0.045 to the 10th power. Okay, changing our percentage to a decimal. So 25,000 times 1.045 raised to the 10th power. Should give us a value of $38,824.24. Okay, if we are going to compound quarterly, means we have to split up our interest rate by 4. Okay, and then we also need to multiply our exponent by 4 as well. I'm just going to put it into one big equation here. It should have gotten a value of $39,109.42. Okay, weekly, same thing. How many weeks are in a year? 52. So I get 25,000 times 1 plus my interest rate split up over 52 weeks, raised to 520 total compounds, $39,200.18.